sklearn, linear model, rich a detailed explanation. The sklearn, linear model, rich class implements ridge regression, a linear regression technique that adds a regularization term to the loss function. This term penalizes large coefficients, effectively shrinking them towards zero. This helps to prevent overfitting and improve the model's generalization performance. Key concepts. Regularization. Ridge regression is a type of regularized linear regression. Regularization is a technique used to prevent overfitting by adding a penalty term to the loss function. This penalty discourages the model from assigning large weights to features, effectively shrinking them towards zero. L2 regularization. Ridge regression uses L2 regularization, which penalizes the sum of squared coefficients. This type of regularization is known for its ability to shrink coefficients towards zero. But it doesn't completely eliminate them. This can be beneficial in cases where all features are potentially relevant but some may have weaker relationships with the target variable. Bias variance trade-off. Regularization helps to balance the bias variance trade-off by reducing the variance of the model, its sensitivity to training data. It can potentially increase bias, its deviation from the true relationship. However, the goal is to find a sweet spot that results in a model that generalizes well to unseen data. Advantages of ridge regression. Prevents overfitting by shrinking coefficients. Ridge regression reduces the model's complexity and makes it less prone to overfitting. Improves generalization performance by improving the model's ability to generalize to unseen data. Ridge regression typically achieves better performance on real-world datasets. Handles collinearity. Ridge regression is particularly effective in dealing with highly correlated features, as it encourages the model to assign similar weights to these features. Interpretability. Although the coefficients are shrunk, they still provide insights into the relative importance of features. Key parameters. YAML, alpha float, default 1.0. The regularization strength. Higher values of alpha result in stronger regularization. When alpha is 0, the model becomes equivalent to standard linear regression. Increasing alpha shrinks the coefficients towards 0, leading to a simpler model with lower variance but potentially higher bias. Fit intercept bool. Default true. Whether to calculate the intercept for this model. If false, the data is assumed to be centered. Setting fit intercept false can be useful for datasets where the intercept is already known or when centering the data manually. Normalize bool. Default false. Whether to normalize the input features. If true, the features will be normalized before fitting the model. Normalization can improve model performance in cases where the features have vastly different scales. Copix bool. Default true. Whether to copy the input data before fitting. If false, the input data will be overwritten in place. Setting Copix false can be slightly faster but can lead to unexpected behavior if the input data is modified. Solver SVD, Kolsky, SAG, Saga, LBFGS. Default SVD. The algorithm used to solve the optimization problem. SVD uses singular value decomposition, which is the default and generally robust. Kolsky uses Kolsky decomposition, which can be faster for small datasets. SAG uses stochastic average gradient, which can be faster for large datasets. Saga uses a faster variant of SAG, also suitable for large datasets. LBFGS uses limited memory BFGS, a quasi-Newton method that can be effective for nonlinear problems. Random state int, random state instance or none. Default none. The seed of the pseudo-random number generator used when shuffling the data. If int random state is the seed used by the random number generator, if random state instance random state is the random number generator, if none, the random number generator is the random state instance used by NP random. Toll float default 1e-3 tolerance for the stopping condition. The optimization process stops when the change in the cost function is less than toll. Smaller values of toll may result in more accurate solutions but could also lead to longer training times. Use a smaller toll value for more precise solutions. Use a larger toll value to speed up training if accuracy is less critical. Selection cyclic random default cyclic. If set to random, a random coefficient is updated every iteration rather than looping over features sequentially. Setting selection to random can improve the speed of training for large datasets, especially when using solvers like SAG and Saga. Maxiter int default none. Maximum number of iterations for the optimization process. If none, the solver will continue until convergence or until the maximum number of iterations is reached. Setting a reasonable maxiter value can help to prevent the solver from running indefinitely if it fails to converge. Positive bool default false. Whether to enforce positive coefficients. If true, the solver will only search for solutions with non-negative coefficients. This can be useful for problems where the coefficients are expected to be positive, such as in certain economic models. Example usage. Python. From sklearn, linear model import ridge. From sklearn, datasets import load diabetes. Load diabetes dataset. Diabetes load diabetes. X diabetes, data. Y diabetes, target. Create a ridge regression model. Model ridge alpha 1.0. Fit the model to the data. Model, fit X, Y. Predict the target variable for new data. New data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Predictions model. Predict new data. Print the predictions. Print predictions. Important notes. Scaling features. It is generally recommended to scale the features before fitting a ridge regression model, as this can improve the model's performance and prevent numerical issues. You can use techniques like standardization or normalization for this purpose. Hyperparameter tuning. The choice of alpha is crucial and can significantly impact the model's performance. It is generally recommended to use techniques like cross-validation to tune this hyperparameter and find the optimal value for your specific dataset. Alternatives. Ridge regression is a popular choice for linear regression with regularization. However, other techniques like lasso regression, L1 regularization, and elastic net combination of L1 and L2 regularization might be more suitable depending on the specific problem and dataset. By understanding the concepts and parameters of ridge regression, you can effectively utilize this powerful technique to build robust and accurate linear models for various applications.